We can start going back to code generation for the rest of it. I have a sample of this that's already, it's already sort of taking shape. Um, and this version inlines things that would be possibly taken care of in checks, like is space here. Um, this is a token, so that's why that's that way. Um, but other things, like is it a member of a particular class? I don't have that, but as you can see, this particular section here, nothing varies here except for the U buffer, and so kind of a pattern's emerging for how that code would be generated. But I want to go back to the token generation. I'm going to have to unstash a bunch of stuff. However, I would like to test something really quick before I get going. I recently turned on Twitter restreaming, and I don't know what that even looks like, so I'm just going to take a look and see what that would, if that would even put live nearby. It actually does. Wow, this is cool. I haven't seen this before. So this is kind of neat. It actually shows you a Periscope thing, shows that you're live, and it gives a link to what you're working on. And I imagine I'm going to be doing this a lot. So I figured, why not? I mean, I have people on Twitter who follow me for some of the other stuff that I'm doing. So at least this is something useful. I was really amazed. I have no affiliation with Restream except for I'm using them as a user, and I got to tell you, I was really amazed at how easy it was to add another service to just stream to. And so enough of that boring stuff. But I just thought I'd mention it. I just wanted to test it. I had never actually seen myself streaming before on any kind of thing. So I still am unsure what this even looks like. It looks like it just shows that you're live streaming, and that's it. So yeah, I'm a little curious what this looks like to somebody who doesn't have a Twitter account. Just give me 1 second if you don't mind. So RWX Rob. I mean, this is one of the advantages of not being affiliate on Twitch, is I can send stuff out to more than a few viewers who might want to see it. It looks like it. That's it. I wonder if it shows in your general profile. It doesn't look like it shows that you're live, but oh well. Good to know. Good information. Oh, we have a notification. I wonder what that's about. Had somebody follow me. All right. Well, this is a good test. Good test. Here's Periscope. That's what I was using. Oh, this is interesting. This is there's some people working on an iPhone competitor, probably from the old iPhone team, who left. And lots of news today. No kidding. There's like so much news today. But I'm gonna just turn that off right now. All right, back to what I was doing. If you're new to my stream, or if you're just seeing it, a Russian spy. Look at the Russian text on Twitter. Здравствуйте. How's it going, guys? I'm just taking a break. We've been moving all morning. We got our new apartment keys. Lest anybody think I'm a spy. We're going to be living in a humble apartment for the next year. It's actually a really great apartment. It's very clean and big enough. And we'll have internet. My wife's setting up internet right now. And we're taking kind of a little break between this time. I did want to recap really quick some things I discovered that were pretty eye-opening about this whole endeavor that I've been doing with the PEGN grammar and the parser and everything. As you know, I went to a lot of effort to make a pretty fancy parser, and RWX Junior had to create proper makefiles. Oh gosh, makefiles rock, man. Anyway, it's been a while, but I love me some makefiles. Yeah, and part of it's really awesome, actually. It's I mean, I was really surprised. It's really, really good. And I mean, I have a reading chair in the corner for my studies and stuff, and my wife's got a whole entire room for her studio that's got a vinyl floor, actually, so it can be cleaned up. It's just really, really great. I'm happy. So anybody's been following the ongoing saga for Mr. Rob and company, that has been something. Yeah. Oh, I've always have to have a chair to think in, and so yeah, nice reading. I've got a whole bunch of books that I've kept out that I need to go that I'm going to be working through over the next year. Um, and yeah. So anyway, back to the coding. So this is the parser. It's not even called a parser anymore. And I gotta, I have a hard time not beating myself up over not seeing this very first. This is it. This is all you need. So if you look at the other parser that I made, I was thinking more in terms of like a traditional parser. I'd been kind of influenced by a lot of the other parsers from the standard library in Go and others I've read about. And the truth of the matter is, because Peg reads the entire byte buffer in, allows you to read the entire byte buffer in, parsing gets really easy. In fact, it's not even really parsing anymore. It's just looking up stuff in a buffer of data. That's it. So you're just jumping around in that data, looking at stuff, but mostly you're just progressing through it. Say, hey, does this match? No. Does this match? Yes. Does this match? No. And it's like really, really easy. In fact, I'm really happy I discovered this. I don't know if you guys remember, I had an entire parser struct for all this. And the more I got whittling it down, I was like, this doesn't even look like a parser anymore. The word's wrong. It's actually just data with a cursor in it, or a current position, whatever you want to call it. And then you just move through it. And it's not even that hard. So, I mean, so many of you are going to be like, well, duh. But, I have to arrive at these conclusions. I'm not as fast as some of y'all. I have to go through it. But maybe somebody will learn along with me while we do this. So, here it is. So, this is all you need. It's a sample check. Too complicated for even the boilerplate code. Yeah, well, it was it got me on board. So, I could go through... you're on DWM? I have no idea what that is. What is DWM? Oh, desktop window manager. Oh, it's the window manager. It is a tiling window. Yeah, I'm not a fan of window managers at all. Tmux is my window manager. That's something Mac and I desperately agree on, even if we disagree on what quick keys to use. Not a fan. Anyway, so we got this check here. And all this really is a struct that's got information about how to tell you that you didn't match. And that can all be derived from the grammar, which is, here, right? And then you've got this function. You got this anonymous function that's in the check. What I probably want to ask Mac about and I want to profile is to see whether this is going to be, it would be worthy to not do an anonymous function here. Or not. I'm still going to have to... I can think of 2 pointer indirections that we're going to have to do, but they're not function lookups, so they should be faster anyway. So, and then this stuff here is just the basic template code that would be added to check you. You have to. This is something we worked out yesterday. Unfortunately, in Go, you have to iterate over every single letter or every byte, make sure those bytes match, and it looks like a lot of code, but it's pretty fast. It doesn't. This is what's going on under the hood. If I had had C, I could have just compared, character arrays between 2 pointer positions and, just pointer arithmetic or something to iterate over it to check it. But that's not possible in Go, and we're not going to beat up Go today for that. We'll do that another day. But when it comes time to port it to C, that's definitely going to be a thing. So this check is relatively easy to make, and it doesn't use anything but the... It must be possible to simplify this by introducing helper functions. I would rather not have helper functions because helper functions are yet another call, and so I would rather not like to do that. I actually had helper functions in here doing all this stuff, but then every time you have one of those, you got yet another function call, and so the question is, which one is more efficient for code that's being generated? I'm going under the assumption that when you have generated code, you can take liberties that you normally wouldn't, and some people take drastic liberties and make code that's completely unreadable. Call cost is this high in this high level situation. This is usability, yeah. But yeah, I completely agree with thinking usability, but Mac, I kind of want to hit the balance between usability and efficiency, and in this particular case, I don't think we're paying anything for this template code. This is, and there's no function call here. This is just iterating over the thing, and that's fine. I mean, having, and I'm okay with that for that particular thing. We may actually use Kiss is fine, but it's not. You're thinking in terms of like general code development, and I totally agree with that. But what I think that you're no, I'm not too focused on performance. I'm trying to maintain a balance between performance. If I didn't care about performance, I'd continue to use a parser like the one I had before. I'd continue to use interfaces so that I could, if I wanted to keep it simple, I would be using interfaces. I would implement them, and I'd be able to have, those be implemented. That's yet more function calls. What I don't want is this stuff that comes out of like the GoPeg thing, which is just completely unreadable. But I also, so I want a middle ground between Lex and Yak and that kind of thing, and this hyper readable stuff. So we're still going to have check functions. So that this is a check function. Yeah, it's not simple code. Yeah, parser interface. I would run. Sorry. If something told me this is a parser interface, it's not a parser interface. This isn't a parser interface. This is just a check, and this is extremely efficient, and it's also completely understandable. There's no problem with this at all because this is being generated code, and this is code that could be managed fine. This does not justify yet another function call. This is, I will say this is like right on the cusp, right? So I had toyed with some ideas earlier today. I actually wrote them out on my iPad, believe it or not. We'll get to that. But what we're talking about is that, so the version before this, when I had node checkers and I had node parsers, these sort of things were encapsulated away in functions that were not functions, in code that was executed through you remember my expect method that would use type switch on the thing that came in, and then it would actually invoke different code depending on what was coming in, whether it was like a string or a buffer or even a different struct, and that's fine. I could even pass checks into the expect thing in sequence, so they could this kind of pseudo syntax going on, but and that was all nice, but that was too much, right? That was being too clever. I think that was doing too much. And then the other side of this is like making this massive 20,000 line single function that does all the parsing, and that's what Lex and Yak do. It's what the GoPeg project does, and I can show you that. So what I really want to hit is the middle ground between that. So a check just returns one thing. It returns the length, if any, or zero of the match. So it takes in the data struct, and it takes its current position. And it says, okay, based on the current position in here, do I match? And if anything doesn't match, it returns a 0. But if it does match, it returns the length of the thing that matched. And so then you can combine that and consume it later down here, which is what we do here. And you can do whatever you want with it. So that's a check function. Now, if you decide that you want do one thing well, right? And that's what these are, right? So we have each check is for, and by the way, this check doesn't really match up with anything. But if you were to match it up with something, these things are going to be generated. These are all going to map to these kind of things here. So these things will be translated into their equivalent code, and then we'll have one check / node function struct, actually, because it's got the data with the function in it, which is a big thing. That was a big thing that came out while I was doing error handling in my first version of this. The errors were not nearly verbose enough, and in order to associate errors with the function that was failing or passing, I had to encapsulate the function with some other data, and so put it in a form like this, where the function is just a first class function essentially, and then that's called, and it's not technically, it's not a first class function because the struct is getting passed around and not that. Anyway, so it does its match and it does its work, but then this allows us some level of clarity and organization, because now each one of these rules here can translate into a check function. So in fact, I might even consider calling them rules instead of checks. They're definitions, whatever you want to call them. The only things that are ever going to actually have a function, though, are anything that has a definition. So over here, the classes I'm seriously debating about whether to inline these. Some of them are pretty complicated, or to make an is function, and I'm leaning towards the is function for all the reasons Mac is saying. We had is functions before. What is an is function? An is function is just is it a member of this character class or not? And that's what we do here. And so that's really fast. And that actually, we were playing with the profiler the other day, and it looks like that's going to be inline no matter what, because it's so small. So rather than us inlining it, we can actually depend on the compiler to inline it, and just go ahead and use them as separate functions and simplify our code. So classes will probably be, now tokens definitely won't be. Tokens will be matched directly. They'll land in that token lookup table, not a lookup table. They'll just be constants, and we actually eliminated tokens that include other tokens, so we don't have to do that whole, well, has it been defined for a second? That came up during generation. So all you can define in here is runes or one or more runes. And a rune can be a byte, a hex, a bit, or whatever. But then that way we can build up a string that then can be matched. And so all the constants will be either string values or numbers, depending on whether they're within the range of Unicode. And that's kind of a tricky thing. Yeah. Hey, hello. Oh, I'm answering the phone. Give me a second, guys. I gotta mute these people. Yeah, which one? Do the wall against. Yeah, yeah, that's good. Yeah, bye. All right. Sorry, they're setting up. How's it going, Neil? So they're setting up stuff. Anyway, so yeah, we're gonna do some code generation. I just kind of want to give a heads up on that. Yeah, I know you can hear everything. I absolutely know that. I don't care. There's nothing to hear. It's like, it's going to be funny though, because I actually go back. I mean, I know you guys can hear stuff downstairs, even in this new apartment. I'm going to have to put the earphones on and like really, really test how much you can hear, because the walls are pretty thin in the new place, and you'll probably hear even more. To abstract all the trivial traverse code in your check rule function body into helper functions to make it readable. Yeah, I completely disagree with that, Mac, and I won't be doing that. If you choose, you can do it manually. Otherwise, it's a mess for the users. No, there's no user here, and that's the thing. You keep thinking that there's a user. This is generated code. This is not going to be. No, I know. There comes the macro. No, this is not. And if you've seen like more than PEGleg, you'd see that this is really common actually, for generated code. And I'm trying to strike a balance between what everybody else is doing. By the way, they would completely I can cite at least 12 different examples of parsers who don't agree at all with that statement, because they're all about efficiency and code generation. It's more important that they be really fast at parsing their grammars that are generated. And so much so that, you get people like Pike in their videos, they'll say, hey, you shouldn't even do one of these things, code generators. You should just write your own parser straight up, because it'd be more efficient, blah, 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 easier to use. And he actually allows himself some performance leeway too, because he does a thing where he throws up all his tokens to a channel, and he uses Go channels for that, which I won't be doing because I want to be able to port this whole thing to other languages. This is not that significant of a thing to want to leverage a language specific feature. And I'm not. I've been thinking about this decision for a very long time. So yeah, I've already moved more away from the clarity thing and more towards the, now whether or not this is it, I don't like this particular code, and this is where I came up with the C code. Because I want to, if we were doing this in C, I wouldn't have to iterate over each one of the bytes and do this kind of byte for byte examination. One of the things I do like about this though is that it keeps us from like reading off the end in a comparison where our pointers are off past the end boundary. No structure. Well, this is generated code. I don't know why you can't get it in your head, Mac. This is like, have you seen what PEGleg puts out? Have you seen what it puts out as its output? Do you judge that code based on that? You use it and you love it. You've been talking about it a lot. So this is the middle ground between generated. Yeah, because it's generated. Okay, generate it better. You want me to generate it better than them? Yeah, and I've already, okay. So just to make my case, because this is Mac, not leave this. There we go. This is what you're gonna get. So point. Where is he? Where is he? Where is he? Where is he? I forget it. Do I still have him here? There it is. No. Where is he? Did I delete his thing? It should be here. I don't see him anymore. I used to have his download, but I don't see it right now. I can just go show you on the internets. So this is what we are going to avoid without going overboard. So Pointlander, Andrew's got a great project. His PEG project, it's really popular. I actually helped him. I refactored his HTML page. His thing, there's references to some grammars I wrote here. This is my first experience with it. It's really, really well done. But it has some problems. And the problems, some of the major problems of this particular tool, I'm not here to slam on it. It's really great. I'm glad it's out there. But this is what the generated code looks like. So when people give me crap about, oh, this is too messy, this is what I'm used to comparing it against. All right. So this is the automatic generated code that was generated from the PEG grammar for his PEG grammar for generating the PEG grammar. And not only does it mix in all these other actions, which don't have any, they're just random because they allow code generation, but they do have some things in here, like they let you, pretty printing and stuff like that, which we will have. But this is where it gets nuts, man. And I just don't refuse to do this. So it's like execute. Okay, well, which one we got? What action do we have? So it goes through all the tokens as PEG rules and says, if I have this, then do this, peek this, then do that. And this is probably something we could learn from a little bit there. But, and then it gets down into this stuff. So this is where this is the rules array. And I like this. This is a lookup table. And this is one of the things that I am going to have, that I was going to have before I saw this. We need a lookup table in order to do real-time evaluation, like to replace regular expressions. We're going to need a lookup table for functions anyway. So here's all the rules, and they're all by number, so that you can go right to them. And now, the other thing too is that they use direct rules. So, and they're just returning true or false, did this match or not? And I I don't know. I appreciate the way that they're doing it, but I also am not a huge fan. So, and then they have this. They have a bunch of extra code that increments the position, and it's like making individual decisions about the stuff as it goes along and proceeds. This is one function, guys. So look at that. That's a single function. All right. And then it goes down here, and we have another function finally. It's like here I take in these two things, and it's got a bunch of stuff. So what they've done is they've really, really isolated this, and this is 100% port, I think, of the PEG-leg C code, which does the same thing. I think this was just a direct port of the C code. That's why you see a bunch of go-tos in here and stuff, which are really effective. They're efficient. I seriously thought about doing this. It's their way of bailing and going on to the next thing. And it's also, there's a lot of scope limiters too, which I thought was interesting. So see right here, this is a scope limiter. And you'll notice that they put scope limiters around stuff even if it doesn't need it. Now, and I really like that, because I had not known previously that Go could just use brackets for scope limiters. I sometimes will use a for that and break out, because that does also iterate. Anyway, so I thought that was kind of cool. But the reason I brought this code into the stream is because this is not sustainable at all in any way. This is code that once you generate it, you depend entirely on the generator, and I'm not okay with that level of dependence. And I'm just trying to make the case that, yeah, I'm pushing for a little bit more, I guess, verbosity in the generated check, which is what I have here. This is obviously template code, and it looks like you're repeating yourself. But that code is the ultimate worst of that, and that's actually really standard. I mean, Lex and Yak and all of the other ones that have that started this sort of code generation for grammars, they really don't care They are completely and totally depending on you to maintain through the generator, and that is something I think is broken. I think that's a broken approach to coding these kind of grammars, particularly since we are not going to have the luxury of including code in PEGN by design. I don't want to force the PEGN grammar specification to be any language specific. I want to give hints to the generators as to what things are important and what things aren't. That's what's up with the 2 dash and the 1 dash. But I don't ever want to have something in here that's like a little bit of code just for Go or C or something. And the sacrifice on that end means that that the code that comes out of it must be more maintainable. That means that the code that comes out of it must be the kind of code, and this is to Mac's point, that you need to be able to go into that generated code and alter it at some point. And, but what level of ease of readability do you have? Is this overboard, right? So, Mac would argue that you should probably even make that simpler for the sake of code maintenance and simplicity, even if it's generated, so you can generate it better and it can be better maintained. And then, by the way, if you want to override one of the automated generated things, say you have indentation that you can't do in the syntax of a spec like this, and then you could come in and add that code, and because it's encapsulated inside of a function, you can either diff or do anything, within third-party utility or one we make, that you can say, hey, don't touch this particular check function. But if you don't have a check function because you have this massive thing of rules here, you'd have no way of overriding that code or making any changes directly to the code. So the difference between the PEGN approach to code generation and every other approach I've ever come across is that we are counting on developers maintaining and tweaking the code after it's been generated without decoupling themselves from the generation process if they want to change their grammar. They should be able to change the grammar and auto-generate and also have changes in the generated code that stay despite the changes to the grammar that can override those things and that can allow them to get in and tweak a couple of those parsers and make sure that they're good. I can just inline or make it a macro. Even Go must support that, or it's no language at all. There's no macros in Go. There's generators, and that's what we have here. We have generators. It would be nice if I could do a macro, and then it would be 0. This is one thing about Rust. Can I just say, you guys know I slam bust Rust chops all the time, but there's you can inline functions. Yeah, the functions. Okay, so Mac, this is one of my. I don't know which functions are being inlined, and actually, let's come back to the inline function idea in a second. If we can manage to make a function that is so generic, you can't force inline functions is the problem. So the compiler decides about what functions get inlined. I brought that up earlier with classes. Classes are strong candidates for being inlined because why? Because all it is it in one of these this rune class, and so the compiler can it's just really smart, by the way. Can analyze that and say it's going to be inlined. And I just found out 2 days ago that we can actually profile the compiler and see which functions are being inlined and which ones are not. And I'm all on board if we can make this into a function. It only has one variable, buff. That's it. The rest of it's a function. So this is a strong candidate for being an inlineable function, in which case then we can just add the function and check whether it's inlined or not. As for and you can inline, you can force it, which would be awesome. And I don't know that you can do that in Go. If you can, I want to know immediately, and I'm definitely going to go look that up. There may be ways to do. Look, there's 2 other ways to do this with Go. One of them is you could do a generator, and a generator is an external program that generates the code and then makes it. It's essentially the same as a macro thing. But I want to come back to the Rust thing. I really like the no cost abstractions in Rust. I want to say that is probably the coolest thing about the whole language. I like the whole borrow checker thing too, but the completely 0 abstraction cost to me is like so awesome, because you can like do these things, you can make these functions that make sense as a programmer, even if you're doing code generation, and be okay with the fact that it's going to optimize everything around it. And I think you have a more fine-grained control over that. I don't know, and this is a new area for me. I'm more focused on writing this app or this utility or this back-end thing, and I've never really got into inlining functions and that level of performance concern. But I am kind of happy to do it because it helps me understand Go internals better, and I think that just makes me a better programmer. You shouldn't be coding for the compiler ever. Everybody knows that's a big anti-pattern. But when you start to get to this level where you're looking at like compiler optimizations and stuff like that after you have a way of code generation you can do for a lot of code, then I think that's probably a fair time to start asking questions like, well, what if I used underlying arrays instead of, which is what they did in that other code, right? This is all an array, as opposed to, somebody was giving me crap the other day about even considering looking at the underlying arrays instead of using slices. Oh, that's not the go way. I'm like, well, it depends on the application, and I'm obviously 90% of the applications should not be messing with the underlying arrays under a slice. But why not? This particular thing, if I could get to the array, would have been much easier of a comparison instead of iterating over it. And iterating over the thing is essentially what I think a lot of the low-level Go functions do. That's why I want to compare. So another option to do here would be, by the way, would be to parse the data from the data stream into a string and compare the strings, right? And that is, I don't believe that that's as efficient. That's going to be building up a buffer unnecessarily, when we could just, use this stuff as is and compare, character for character, or do this essentially the same thing if we were comparing, bytes for bytes, and be basically, doing direct memory comparisons in C if we were doing it that way. So yes, if this could be inline. Now, the question I have about that is, how can I see if that's going to be inlined? And that is completely new territory for me. I didn't even know there was a Go compiler, the Go compiler profiler until 2 days ago, and I found out that there was. I know how to generally profile performance, in terms of race conditions and things like that. So when people say, do you know how to profile code? That means a lot of things to different people. To a database applications team, it might mean, oh, you want to know where that memory is going to be wasted, where it's going to be used, where it's going to be written, when's the garbage collector going to kick in. You might want that level of knowledge about how everything is going on in what gets generated from your code. But most of the time when someone says profiling, they mean like, oh, they are checking for race conditions and higher level things. And so it's so profiling your code at this low level is a skill I like to get into more. And is not something that most Go programmers would probably be doing. They should, I think, but they probably won't. It depends on where code's being used, obviously. And so I don't quite know whether right now GCC GNU gprof, yeah, there's a bunch of stuff. Yeah, I want something like that, and I'm pretty sure that there are tools out there that are that level of good for Go. I just haven't encountered them yet. I've been coding Go for 6 years, but that level of profiling has never been a requirement from the projects that I'm doing. Can't have loops or switchers. How did you read that? Greg, you mind telling me where the source is on that? Was it in the spec? Was it in the online spec? So, yeah, compiler optimizations. Ooh, good for you. Thank you for finding that for me. Compiler and runtime optimizations. Yay team. This is the kind of stuff that I just never had a reason to really read before. So I'm going to spend a little time reading this with y'all. Zero width types in interface values. Putting a zero width type in an interface value doesn't allocate. Interesting. Interface value word size. Let's see. String and byte. Map lookup by byte. For a map, type mstring doesn't allocate the temporary string. It doesn't allocate. What does that mean? Oh, here we go. Inlining. The GC flags love to observe the rest of escape analysis and inlining decisions for the GCC toolchain to explain the output of GCC flags -m. Ooh. Escape analysis and inlining. Go compiler does global escape analysis across functions and package boundaries. Where it gives up. For example, anything assigned to any kind of indirection is considered escaped. I was going to say, other things that can inhibit analysis are function calls, package boundaries. I was afraid of function calls doing that. See, that's why I want to do function calls that are. I want to check whether lookup tables with anonymous functions in them are faster than functions that are referenced by symbol in a lookup table, and if that would actually make it inline more. Package boundaries, slice littles, subslicing, and indexing. Full rules are too complex to describe, so check -m output. Interesting. Interesting. Function inlining. Only short and simple functions are inlined. What does short and simple mean? See, so this is where so the inline functions that we wrote for the other project, for example, the old one, I still have these around, are here. And so all these is functions, I think, are candidates for inlining. 40 or less expressions, no loops, no switches. So you see this here? This to me is like an easy option for an inline. No loops and no switches, right? What do you mean no switches? No ifs? That doesn't make sense. So yeah. Okay, fine. I'll read. Function inlining. Less than 40 expressions does not contain complex things like loops, labels, closures. Ooh, so you don't use. I'm not going to use go-to labels at all. No closures. That makes sense. No panics, recovers, or selects, or switches. That means it must just be if statements. If it's if statements, then, you know what? That's really weird, because I was just reading another thing about optimization. It was suggested using switch. I think it was a C blog, and it was suggested using switch over a function lookup. No, it was JavaScript. It was suggesting using switch over a function lookup table because it was actually faster to switch. If else's were the slowest. Function table lookups were second fastest, and switches were absolutely the fastest for the JavaScript. So it completely depends on the language, and so using switch here would be a problem, right? So this means ultimately making everything into an if statement, which is fine. I have no problem with that. Function inlining. Is there idioms? Optimize memcil or for a slice or array, loops of the form. Zero value element array, and say are converted into efficient runtime memory calls, memory clear calls, issue and commit. Nice. I need to really study this. I'm gonna read this really deeply. I have a need for it now. I didn't need as much of this before. Non-scannable objects. Garbage collection does not scan underlining buffers or slices. Channels and maps when element types do not contain pointers. This allows to hold large data sets in memory without paying a high price to do garbage collection. For example, the following map won't visibly affect GC time. Interesting. That's really interesting. Yeah, there's a lot to read here. There's really no way to know this, so I'm going to read about. I want to read about how to do this profiling to determine if you have been inlined or not, and that is a task I have never done, so I'm going to figure that out. And that is you know what, I'm kind of thinking that that's an essential task for me to do before I start writing code generation, because I don't want to generate or experiment with code that I know is not going to get inlined. And to everybody's point here, we should be considering whether this function can be inline. It obviously can't if it has a loop, right? So that is not an inline function. So how much penalty do we take here on this? I wonder if it's any loop. It sounds like it is. It sounds like it's any loop, right? But there's really no way to know unless we do it. Only short and simple functions are inline. To be inline, a function must contain less than 40 expressions. Less than 40 expressions. It can't have closures, and I don't think it can be like loops, labels, closures, panics, recovers, selects, switches. We don't have a select or switch. We do have a loop though, but how is a loop complex? I guess a loop is complex. I guess it is because it can't. Otherwise, if we can inline it, it could just write out what it is, right? With if it was if then statements, it can do the whole thing as assembly. You can kind of think of what the assembly would look like underlying that. You can't represent a loop structure with just plain old assembly. I mean, you'd have to jump and stuff. So So yeah, I think that's why I can't have a label too, because it's another long jump. Um, yeah, interesting. This makes me really, 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 really want to get into compiler theory. Can I just say? I mean, I know that's probably sadistic, and a lot of you are reading this, watching this, and from Twitch and stuff. You're like, why would you care about this stuff? But it's just super, super interesting to me, um, how that stuff gets done. Um, so let's just put it this way: there's no hope of this. If I cut that out and put that into a function, right, which is relatively easy, obviously. Um, I could just do this. We could say func. What we could say? I could say what would we say? We'd say match. Uh, let's say peak, I guess, or peak or expect. How about that? How about that? We could say expect. Uh, and this is kind of what I had already in my other one. That's why I'm feeling kind of reminiscent on this. So we return an int, and then I could use this for anything. Return return the length of the buffer, and I mean I could even return the buffer itself if I wanted to. And then we say expect a string, I guess. This is again, I already wrote this code so for something else. So restrictions on inline functions. I mean, in Go, inline functions are basically castrated. Well, yeah, probably for good reason though. Again, Go is primarily a Python replacement. Primarily, it even says so in the first paragraph of the main Go page. So, yeah, it was also made by two of the engineers who were instrumental in creating the C language. So they have their reasons. Ken Thompson and Pike Thompson, who designed D, which became C or B, sorry, essentially. So, and again, I know I'm like overly obsessing about performance here, but I figured I've already done the easy way and I got that to work. So now I'm kind of want to add a little layer of performance to this code generation. And, I could throw in an expect function like this, that, covers it completely. And, we'd be fine. So, what happened to A? I don't know. So, and then, down here, we could just say, this is kind of what I had before. It'd be like, length, length plus equals expect, u. And then I could do this. I could make a function for this. And I can make expect, I can do this. I can do expect u, and then I can do expect, this is what I already have actually, expect a blank, actually I don't want to switch on that, so I could just keep it low level here and do expect u, expect a space, and even put those two together, and join those together, and that's something I could do in code generation. So I could actually do that. Since these are both functions, I could just do this, and then I have, I know it's more beautiful, but the problem with that is that, you saw the other code we had. The code was absolutely beautiful, but at that point, it's like, do I even need a check function? My check function is like just expect this. And I already have that. I've already developed that. We developed a very elaborate expect that type switches on everything. And that's what that's where I got into the mess with like taking any particular type. I'm going to remove the type switching here, but do you see what I'm saying? It's like if I say, well, I expect this and this and this. What I could do in the generator, though, that would make the whole entire thing more efficient. So I am glad I'm hearing Mac out here. Is that if I detect that I have so here's the PEGN, right? So if I detect that I have a type string followed by a type rune followed by a type string, those can be inlined in the code generator. So the code generator can be smart enough to say, oh, I have inlineable stuff. and it can inline all of that together and then only check one thing using the expect. The same project in C to compare the two, see which is easier and work better. Yeah, well, of course, I'm going to do it in C as well. I will eventually do this whole entire project in C, but I need something in Go right now because I need Go code in order to do the other projects that are coming out of this. That's what got me into all this. I want to finish my knowledge in apps, and I got 3 languages I want to write: EasyMark, DataMark, and DTime, and a bunch of base SQL. Anyway, so what I'm saying here is that this could be the code that is generated from this, and I'm already much happier with this. In fact, I don't even need a buffer. In this case, I can just do this, and I could just do this. I could just do return expect UR, and that is like really that is the holy grail. I mean, that I keep using that word, but that would be the absolute best. Because it's it's doing everything we need, and yeah, that would be the best. Now this implies a smarter code generator. And let's be honest, the code generator in some sense is a compiler. In a certain sense, it is a compiler. It's taking the AST and it's compiling. The result of its compilation is code, not a linked shared object, but it is in a very real sense it is compiling it. And I can tell you, this is also motivating me to crack open those big thick compiler theory books that I have browse through, but I have in my reading setup for computer science, setting up my own computer science residency. And I've got several books that are traditionally read and consumed for this kind of thing. So in one sense, thinking about this as a compiler, I think is the way to go, because God, look what we just did. So I have one function call, but that's a very simple function call. It just checks to see if each of the letters is a match, and then we go with that. I have time for that. Prioritize the overall project. No, I do have time for it. I know you want this project. I know most people do, but the project is, look, don't worry. I only read that stuff like when I'm sleeping or I'm on the pot. It's like my reading time when I'm like not, when I'm relaxing. The mackerel comes out yet again. I'm okay with this one. So here's another way I'm okay with this. Okay, so all those if statements and everything that I had going on, right? The number of statements in there and code that was being copied over and over again, plus the math involved, it's still the same complexity in terms of overhead. The only thing I've incurred here is one function call, but I have also saved what would have been 2 or 3 function calls by optimizing or inlining my own grammar. So that means that if I come across, I've got to make a note about this. I'm going to make a note, otherwise I will forget. So I'm going to say function over inlines. I'm going to put a thing here that says inlined grammar rules. When a rule can be combined with a rule next to it because they are classes or just runes. I'll say usually. Usually because we combine them and then evaluate the entire thing with one. That's all. The only problem with that is that we will get hi Sartini. We are going to lose a little bit of grammar specificity on this, and that's kind of okay. I am a little bit leery of it. Uh, because why? Because the error message, right? So I really don't want to throw away error messages here. But so if I cram together the inlines here, I lose the ability to identify which piece of it has failed. So, I have to say at the overall level, this overall check has failed. I wouldn't be able to say uh, that the space was missing, or I was expecting an R in R, or I was expecting a binary digit. So that level of really great error reporting goes out the window when I do it this way. And I'm gonna kind of put the brakes on this for a second. I got to really think through this because that defeats the purpose of this entire effort, which is to not just make really effective. That's fine if you're gonna do a check, but it's not fine if you're gonna do node parsing. And actually, I'm glad we talked through this because this means that I've been wondering if I needed checks and parsers in addition to this. The difference between a check and a parser is that the parser takes the output of this and actually grabs the value and creates a node, allocates the memory for a node and everything, and adds it to the parser tree. And that's important. It needs to happen, but it's also a lot of extra overhead when you're just checking something to see if it matches. If you're just checking something to see if it matches, the question then becomes how much specificity do you want over performance? Do I want to know that this element was the thing that missed? It missed on the space in the middle, or do I mean, obviously this is a bad example, right? Because this could be represented like this, but I don't know. So usually, if somebody's going to put if someone goes to the hassle in their grammar of being that specific in their grammar, like this, right? Then I feel like it follows that the error messages should match that level of detail. So, I could have just put a space here and say, hey, you missed this thing in your meta, and that's not as big a deal. But if somebody actually went to the problem of calling out specifically what was missing as a separate rule, I feel like each rule should have its own error functions. To sort of error message to whatever detail you like. Yeah, but the problem with that is I no longer have the specificity of a check for each one of these things. So, for example, and this is a bad example because this is checking for a specific set of things, right? It's PEGX includes errors in the grammar. Yeah, it puts the errors in there, right? So you can put them wherever you want them. Yeah, I don't think that's a good idea. I just don't. I think I don't. I think having the error messages. We talked about doing that for each level, and I really don't want to clutter this file because this is where you're doing your coding, and you don't want. You know what it is when you get too many document comments in anything you're coding, right? It gets really annoying. You can't see the actual syntax, and I'm not a fan of that. So, but I am a fan of providing. Well, you know what? You do raise a good question, though. Where are we going to get this context from if we're doing code generation, right? So words U and R up to this point, this like rewinds me back 4 days or so when I was doing error messages, and this is required, but not when a person can read. Was going, yeah. So going back like 4 or 5 days when I was doing error messages, the question came. All right, I have the identifier, which can be grabbed from the grammar. I have the PEGN grammar, which can be grabbed from the grammar, obviously. But where do I get the description from? And I entertain possibilities. Has relevance to the overall decision about whether we make an expect function and we do inlining or not. So this is why this is coming up. So if I go back to this thing, for a while I was saying here, I was doing well, if there is a thing immediately preceding it, then that's the error message, right? Well, no. I mean, that I like it, but I don't like it because it's first of all, it forces it. I just feel like it's gonna detract from the clarity of the grammar. This is also the reason that I'm not really entertaining some of these other really great syntax ideas for things like recurring comma lists and stuff like that, because I just feel like they make the grammar no longer simple to read. And to me, the number one priority above everything else, this is what Peg brings to the table, is a grammar that anyone can understand with like 5 minutes of instruction. So like, this, and most of the time if they know regex, they'll already get it. This means, an optional, this means 0 or more, this means 1 or more. Hey, we have gathering, done. There's not a lot of extra cognitive overhead to understand the grammar. That is my absolute priority, because I want to have grammars be really, really easy to grok. And I want to replace regular expressions as much as possible. I love them, but I want to replace them as much as possible with inline grammars that can be used as to compare, for matches and stuff within code, as well as in generated code that's optimized or whatever. So the idea of putting this verbose error message associated with this description, words UNR or something like that, as much as I love the error messages that come out of that's a little bit of too much. So where does it come from? Well, I definitely am planning on having the description option be here. And up to this point, that description, the plan anyway, is that description would come from the README itself. And the README is also where the errors testable error are going to be. It's also where a really full summary of any of these items is going to be. So you would have, there's nothing here right now, but that's the idea, is that you would show something and then you would show its outline, you would show its AST. So here we go. So you'd have this, and then you would show the thing, and then you could compare the two. But the bottom line is this, and this is not original. This is coming from like the Go project. But we will be parsing the accompanying. So there'll be two files in any grammar. There'll be the grammar.pegn file, and then there'll be a README file, and there in the generator will be smart enough to see for grammar if there's a README file and there's a header that matches, it can derive some of the information from that. I don't want to go so far as to have a YAML file for this. We could do that as well, right? We could have the YAML file accompany the grammar file that has all of the extra information about it that could then be used to generate README files. But I just think starting with the README file is nice. And YAML actually, Pandoc, this is not supported in CommonMark, but in Pandoc you actually have the ability to specify YAML headers and stuff anywhere in the grammar at all, which means you could actually have them within a header section to say, hey, this header, this is stuff for that. But I think using, this is one of the reasons I'm making a PEGN grammar, is I want to be able to parse EasyMark in a way that's much more consistent and speedy in one pass and not two. And so when that happens, I want to be able to put that, I want to be able to say, okay, the first paragraph after here that starts with whatever is the description, the error description line, right? And so that would be, maybe it'd be in italics or something, and I could put that, and then that would be mined out of the README file at generation time, and then that would populate this particular area right here. Now, the current plan is to have the two files together. I've played with all kinds of ways of doing this. At one point, originally, the entire grammar was going to be all Markdown, and that was way the wrong direction. Because I found as I was developing the grammar, which was really great that I got the experience of developing this grammar, because as a grammar developer, I was like, I don't like that. I want to do this. And that was when I started chucking notes. I was like, there shouldn't be any notes and comments in here unless they're absolutely essential. Like they're like prosaic or rhetorical, where they're like saying, hey, this is one of the, like for here, right? So here is a constraint, and EBNF uses comments for constraints all the time. And these are designed to communicate to the developer, hey, here's something extra you need to put in your code that I cannot copy in the thing. I'm going to take a quick break. My wife just got back, so I will be, I don't know how soon I will be back. I'm going to go ahead and end the stream. Give this some thought though, if you'd like, if you wouldn't mind, on your own, if you want to. But I have a feeling that I'm going to be okay with these expect functions. But I don't know how okay I am inlining things like this, if it means sacrificing the errors involved. Another thing I could do that it's a generation, it would be a little bit annoying, but I could actually create an array. If I'm going to inline the things, it would speed up the checking of those things. But then if there's an error, what I could do is I could identify the boundaries for the different things. So I could actually add something like this. I know this isn't too much of an overwhelming thing, but I could say this. I could say, word boundaries, and I could say like, so I don't know, types or errors or something. And so if I had subtypes, I could, I mean, I won't call it errors, but let's say I did, right? So I could actually have an array, and I could have, the description for the first part could be associated with the description for the second part. Another way of doing that is to just break everything down into as one rule per check, and that doesn't fly for stuff where you are combining when you're combining runes. And so maybe I just need to be okay with that and say, okay, I inlined all your rules together. So you have in this you have an error on this because I was expecting a space, or I was expecting an AR or something like that. And frankly, I'm kind of inclined to think that that's going to be okay. That's enough information to know what's going on, because you're not going to be providing documentation for each one of these individual things. And if you are, you should be calling the expect for that. You should be calling the check for that anyway. And that check's going to give you a different error message. So this has been very helpful. I'm glad once again that I heard everybody out on this. Flip-flopping on this, if that's what you want to call it, fine. Let's put it this way. I am willing to trade one function call for inlining 3 different rules into a single rule check. You see what I'm saying? So that's the takeaway. It isn't a flip-flop. It is a combination. That was a completely understandable trade-off given the fact that we had inlining. I would not have entertained it before that. If we had not done the inlining, I wouldn't have done that. But the inlining not only gets us, they just try both, and you find out which one you like better. Ironically, the fact that I'm doing inlining would actually support maintaining this as an individual function in there. Because why? Because now we're only having one. There's only one function that we're iterating through, and we don't have to do all the other ones. So we almost don't need this expect statement here. But if I am going through, there's going to be a slew of these things for the grammar, right? You're going to have at least one of these for the entire grammar. Not to mention, I'm still debating about how to do the node one. The node one, we're probably going to have a generic node generator that wraps a check. As opposed to having node parser functions, because this is a combination I got to talk about with Ethan today, but this is a combination that I think has always been kind of in the works. You have this notion of like, I want to check if this thing is there, and that's a different need than I want to take what is there and save it off and use it later. And they need to be separate. So right now we're just going to expect that we're going to get the thing, and then there'd be some function that wraps the checks and says, okay, give me a node from that thing, right? And then those would be called. Unfortunately, I don't know how that will work. Well, that's not a thing we need to worry about right now. We can do that as we get going on, and then we'll go ahead and print it. And that'll give us some data there. I guess we couldn't put the expect in here though, because it has to be out here. So I don't know. That's expect might actually have to be a function that becomes a part of it. This is one of those questions where I might have to actually make. Well, I'm just adding back what I took out. There we go. Now it's now a parser, right? So as soon as I add expect, I think expect is totally okay. We could do a func expect. I gotta go. So we're gonna do that later. When I come back, I'll add some more. I'll add the expect function back. I don't want to get crazy with the expect function. I don't want to go to where I was with it before, where I have this type switching going on. Let's take a bloody. I'm ready for the weekend. Good job. See here. This is really cool and also slow, like really slow in comparison to what I'm talking about doing. So I've learned something here. I'm going to take away the best parts of what I learned by prototyping it with this method, which works totally fine. But then I'm going to take away this type checking thing, since now all we have is just strings for everything. And we're going to go ahead and do that. And then I think that'll be a lot faster, and we won't have to deal with it. This is, Max suggested that we have some sort of like something that's cleaner. I still didn't want to add this back, right? It had to be something in between this and the other. And so I wanted to play around more with, well, what happens if we expand all of the code out and make it, you know, unreadable essentially. But let's like kind of pare it back as we go, and make only the best of sacrifices for the balance of code clarity and performance. Because I don't want this. This is not slow, but you know, it's not as fast as it could be. It's definitely not as fast as some of those things that are completely unsustainable. I do like though that the code for is, you know, the different expecs is caught in here, and so we'll be reusing some of those methods. And when I come back, I will definitely be adding that expect function to. I'll be fleshing out the expect function to the data. I don't know if that's enough to change the name from back to parser, since there's no parsing going on. I do think data.expect is pretty fair. I kind of like how that would sound too. So it'd be something like this, right? It'd be function. Let me put a receiver here. Data and expect, and then I just put a string, and yeah, and just put a, I don't know, and then we just put and we return a length, and then return 0. But that would just be, that little thing that we did. Parsing equals it goes to matching. Kind of does. Potatoes. It is sort of that. I mean, I think parsing and matching are distinctly different now, only because I've dealt with people that are writing the check code versus the parsing code, and they're different. The parsing code is only one step, though. It's just like, hey, now take what you found and give it to me, right? But it's more than just returning true or false. I found a match. Oh wait, wrong thing. What am I keep doing? I keep typing the wrong thing. All right, there we go. And let's put this in here. Now we'll call that a day. I'll go ahead and put buff here. And potatoes. I'll return length buff, and that's fine because now we know where we are in the data, and such. And again, I'm only going to put a string in here. We're not going to have a lot of different things. I think this is a happy medium between the things that we were talking about. I'm going to actually change this in the test. Make sure this still works. Undefined length PEGN.go. What did I do there? Oh, right. Let's see here. So we don't actually need this anymore. So it'd be length and length, and then this can go to, because this assumes that it's going to be taking it from the current position. So we can only call this if we advance the parser, which is fine, or the data pointer, the cursor, or whatever. So undefined expect. So now let's call this. And I think we'll be back to normal p.expect undefined p, because it's d now. Data.expect, and we passed. And I think we have a good save and a good end to the stream. Thank you very much for stopping by and giving me all your feedback. I know you guys are, it's funny because the more you get invested in this, the more strong you are in your opinion expression, which is great. I love it. And when we come back to this, I'll do some more parsing, but